This locomotive was designed in 1972, and it is still working today, hauling freight across America more than 50 years later. It is not preserved. It is not restored. It is not in a museum. It is in daily revenue service, doing the same job it was built to do half a century ago. The EMD GP38-2 and the SD40-2 are the most successful diesel locomotives in American history. Thousands were built, thousands are still running, and they descend directly from the engine that killed steam, the EMD prime mover we covered in the F-Unit video. This is the engineering that made a 1970s diesel outlast almost everything built since, and why railroads still choose to run them. The diesels that finished what the F-Unit started. In the F-Unit video, we covered the EMD 567 prime mover, the two-stroke diesel engine that ended the steam era. That engine did not stop evolving. In the 1960s, EMD enlarged it into the 645 series, the same fundamental architecture with larger cylinders and more power. EMD also moved away from the streamlined cab unit format of the F-Unit toward hood units. Locomotives with a full-width cab at one end and a narrow hood housing the machinery, giving crews better visibility and mechanics better access. In 1972, EMD introduced the -2 line, a refinement of its existing locomotives with improved standardized modular electronics. The GP38-2 and the SD40-2 were the two most important members of that line, and they became the best-selling, longest-lasting diesel locomotives America ever produced. What made them last was not radical technology. It was the same philosophy that ran through the F-Unit, proven engineering executed for durability and maintainability rather than peak performance. Both locomotives were built around the EMD 645 prime mover, a two-stroke V-type diesel engine directly descended from the 567 that powered the F-Unit. The number 645 referred to the cubic inch displacement of each cylinder, up from 567. The fundamental architecture was identical to what we covered in the F-Unit video. The two-stroke cycle producing power on every revolution, the roots blower scavenging the cylinders, the unit injectors delivering fuel to each cylinder individually, the modular cylinder assemblies that could be replaced one at a time. Every defining feature of the 567 carried forward into the 645. The GP38-2 used a 16-cylinder 645 without a turbocharger, a naturally aspirated roots-blown engine producing around 2,000 horsepower. This made it mechanically simpler, more reliable, and cheaper to maintain. The GP38-2 was the locomotive railroads bought when they wanted a dependable, no-frills workhorse. The SD40-2 used a 16-cylinder 645 with a turbocharger, producing around 3,000 horsepower. The turbocharger recovered energy from the exhaust to force more air into the cylinders, increasing power. The SD40-2 was the locomotive railroads bought when they needed more muscle for heavy mainline work. This distinction, turbocharged SD40-2 versus roots-blown GP38-2, defined the two locomotives. The GP38-2 traded power for simplicity and reliability. The SD40-2 traded some simplicity for more power. Between them, they covered nearly every job an American railroad needed done. And both used the same fundamental engine, the same maintenance procedures, the same spare parts philosophy. A railroad that operated both types could maintain them with largely overlapping knowledge and inventory, an economic advantage that echoed the standardization logic of the K4 decades earlier. But the engine was not what made the -2 line special. What set these locomotives apart was hidden in the electrical cabinet. The defining feature of the -2 line was its modular electronics. EMD replaced the older hardwired electrical control systems with standardized replaceable modules, plug-in cards that controlled specific functions of the locomotive. When something failed on an older locomotive, a technician had to trace the fault through a maze of wiring and repair it in place. On a -2, the technician could identify the failed module, unplug it, plug in a replacement, and have the locomotive running again in minutes. The failed module could be repaired later, off the locomotive. This modular approach dramatically reduced the time a locomotive spent out of service for electrical faults. It made troubleshooting faster, made repairs simpler, and reduced the level of specialized expertise required to keep the locomotive running. It was the same maintainability philosophy that ran through EMD's entire design history, applied to the electrical system. The SD40-2 also introduced a new truck design, the HTC truck, a 3-axle design engineered for better weight distribution and improved adhesion. The truck let the SD40-2 put its 3,000 horsepower to the rail more effectively, especially at low speed when starting heavy trains. This was the other distinction between the two locomotives. The GP38-2 rode on 2 4-wheel trucks, 4 powered axles total. The SD40-2 rode on 2 6-wheel trucks, 6 powered axles total. More axles meant the SD40-2 spread its weight and its power across more wheels, giving it better traction for heavy mainline work. The GP38-2's 4-axle design was lighter, more nimble, and ideal for local and branch line service. The combination, the proven 645 engine, the modular electronics, and the improved trucks, produced locomotives that were powerful enough for the work, simple enough to maintain, and durable enough to run for decades. Railroads bought them in enormous numbers. Over 4,000 SD40-2s were built, over 2,000 GP38-2s. Together with their close variants, they became the backbone of American freight railroading through the 1970s, 80s, and beyond. No other diesel locomotive design achieved this kind of production and longevity. But production numbers are not the real story. The real story is that these locomotives simply refuse to wear out. 50 years after they were designed, GP38-2s and SD40-2s are still in daily revenue service across North America. They work for short-line railroads, regional railroads, industrial operations, and even Class 1 railroads that keep them for specific duties. The reason is economic. A GP38-2 or SD40-2 can be rebuilt, its engine overhauled, its electronics updated, its running gear reconditioned, for a fraction of the cost of a new locomotive. And because the design is so simple and so well understood, the rebuild produces a locomotive that is nearly as capable as a modern machine for many jobs, at a small fraction of the price. A modern locomotive costs millions of dollars and carries complex emissions equipment and sophisticated electronics that require specialized support. A rebuilt SD40-2 costs a fraction of that, uses a proven engine that any competent shop can maintain, and does most jobs perfectly well. For a railroad that does not need the latest technology, the old locomotive is often the smarter purchase. The modular electronics that EMD introduced in 1972 are part of why this works. The locomotives are genuinely easy to maintain. The parts are available. The knowledge is widespread. Generations of railroad mechanics learned on these machines, and that expertise has kept them running long after their designers expected them to retire. The GP38-2 in particular has become the definitive short-line and regional locomotive. Its simplicity, no turbocharger, 4 axles, straightforward systems, makes it ideal for smaller railroads that cannot support complex equipment. Decades after production ended, it remains the locomotive of choice for a huge segment of the American rail network. And the engine lineage continues. The 645 that powers these locomotives evolved into the 710 series that powers EMD's later locomotives. The 2-stroke architecture that began with the 567 in the F unit, the engine that killed steam, is still in production today, still doing the same fundamental job, still built on the same principles. The GP38-2 and SD40-2 are the point in this story where the F unit's engineering became permanent. The F unit ended steam. The GP38-2 and SD40-2 proved that EMD's diesel-electric architecture was not just transitional. It was the durable, permanent foundation of American freight railroading. The GP38-2 and SD40-2 represent a different kind of engineering achievement than the extreme locomotives. They were not the most powerful, the fastest, or the most technologically advanced. They were the most appropriate, engineered so well for their purpose that they became effectively permanent fixtures of the rail network. A locomotive that runs for 50 years in revenue service is an extraordinary engineering accomplishment. It means every system was durable enough, every component was maintainable enough, and the overall design was sound enough to survive 5 decades of the hardest work in industry. Very few machines of any kind achieve that. The engineering that made it possible traces directly back to the F-Unit's 567 prime mover. The two-stroke cycle, the roots blower, the unit injectors, the modular construction, the relentless focus on maintainability. Every principle that made the F-Unit's engine dominant made the GP38-2 and SD40-2 immortal. This is the completion of the diesel-electric story that the F-Unit began. The F-Unit proved the concept and killed steam. The GP38-2 and SD40-2 perfected the execution and became permanent. Together, they defined the diesel-electric locomotive as the enduring foundation of American railroading. These locomotives are not celebrated the way the Big Boy or the GG1 are. They have no glamour, no streamlining, no dramatic story. They just work, decade after decade, without fanfare, doing the essential job of moving freight across a continent. What is under the hood of the GP38-2 and SD40-2 is the most successful diesel engineering in American history. Not because it was the most advanced, but because it was durable, maintainable, and appropriate to a degree that no competitor matched. The engine that killed steam became the engine that never dies, and it is still out there, working right now. The EMD GP38-2 and SD40-2 are the most successful and durable diesel locomotives in American history. They descend directly from the F-Unit's engine, and they prove that EMD's diesel-electric architecture was the permanent foundation of American railroading. Not a transitional technology, but the real thing. This is part 6 of our What's Under the Hood series. The earlier videos covered the Big Boy, the GG1, the F-Unit, the K4, and the Class J. All are linked in the description. Next, we cover the Southern Pacific GS4 Daylight, the streamlined high-speed steam locomotive that was engineered for pure passenger speed, a very different steam philosophy than the freight power of the Big Boy. Subscribe so you do not miss it. There is more American railroad engineering to explore, and we are working through it one locomotive at a time.